Hello and welcome to Prairie Pulse. Coming up a little bit later in the show, we'll learn about the old Ukrainian tradition of making Pasansky eggs. But first, joining us now, our guest is Chief Meteorologist for WDAY-TV, John Wheeler. John, thanks for joining us today.
Thanks for having me.
Well, as we get started, tell the folks a little bit about yourself. You've been around here a long time, but where are you originally from?
I was born in Baton Rouge, Louisiana. My upbringing was largely a feature of my dad's education. He was getting his master's degree in math at LSU when I came along, and I don't remember Louisiana very much, but we then moved to Alabama, where I did my early growing up. My dad was a teacher at a preparatory school in central Alabama, and my mom taught public school, and then he decided he would get his PhD when I was about 11 years old, and we moved to Wisconsin. So then I became a Midwesterner, and I finished my high school years in Iowa, in northeast Iowa, where my dad was working in education and curriculum development, and my mom was a high school teacher and play director. And then I went to Iowa State and got into meteorology as a career and worked at one station in Iowa, but most of my time has been spent right here in Fargo, North Dakota.
Well, we may get into more of that, but you're here today to talk about the mild winter and climate changes, I guess. Kind of your passion, I hope. But this past winter, one of the mildest on records. Tell us about that. How does it rate historically?
You know, that's a good question, and I would first point out the word historically. That when we talk about, you know, the warmest ever, what we really mean is the warmest on a period of record. And weather records in North Dakota, preliminary records go back to, Bismarck has the oldest continuous thermometer record dating to 1875. Fargo's pretty old, 1881. Other places started later. And of course, over time, there are more and more instrument sites. So when we talk about the old records, we're getting our information from a very small number of sites, and now we have a great many. But this basically stacks up as the warmest on record, and certainly one of the warmest by any standard. And it's not just the winter, but the fall, winter, and spring so far stacks up as the warmest observed.
Mm-hmm. Well, and the previous winter, 22-23, was a bad one compared, but I guess most of them were bad compared to 23-24. So in your view, or what you're hearing, does this mild winter sort of forecast more mild winters, and is it due to climate change?
Well, that's another very good question, and I think a lot of people are confused about the difference between climate and weather. Weather is the daily weather, and here in North Dakota, you know, you can't count on the weather being the same 1 hour to the next, much less one day to the next or one winter to the next. So we have a great deal of built-in natural variability of weather in our climate. So our climate presupposes a lot of variation. So the fact that last winter was cold and this winter was very mild doesn't really mean that much, because that's just the way our weather works. Mm-hmm. Climate is the overall pattern, and we find climate change in North Dakota weather records as we see things change over time. So one warm winter doesn't really signal anything. There have been warm winters in the past, maybe not quite as warm as this one, but there have been warm winters in the past. And the fact that, as you pointed out, last winter was kind of a bear of a winter, suggests that maybe we're living a little too much in the present if we use just this winter to say there's something that's going wrong with our weather. Climate change is found in the way that changes begin to manifest themselves over time. We see an increase in this weather feature or a decrease in that over the course of years and decades. That's where climate change is.
Mm-hmm. So what do long-term models suggest? Well, let's just say for this summer, in terms of temperature and rainfall, do weather patterns think, you know, we have dry seasons, wet seasons, but what does it suggest for this summer?
Well, I'd like to point out two things there. One is that when you're talking about models, again, there is a distinct difference between weather modeling and climate modeling, because the physics are completely different. A weather model takes, and by the way, it's kind of interesting, the best computers in the world today are the fastest, most sophisticated computers in the world today are used in two arenas: spying and military, weather and climate. Those are the best computers we have. So we're putting a lot of money into this because of the cost, right? But when we're talking about what a weather model does is it takes the current observations, the atmosphere at the moment, and uses physics to predict how those conditions will change over time, literally increment by increment. That's not what a climate model does. A climate model takes the world or the region and then changes the inputs, the various things that impact that climate, and then comes up with sort of what averages would be like into the future, or if you wanted to construct it, what are the averages of today based on the conditions of years ago? You can run that as a test. So the two types of modeling are distinctly different. And when you talk about what are the models suggesting for the summer, the mathematical physics models that we use to predict the weather over the next few days start to lose their reliability once you get a week or two out, and then we can do other things to look at a couple of weeks out. But when we're talking about the upcoming summer, what we mostly look at are large-scale weather anomalies around the world. What is the sea surface temperature doing? Where are there pockets of unusual weather right now? Where are there various circulation patterns around the world that might have an impact on the jet stream and general weather? And then we can use that to predict with a certain amount of vagueness what a summer would be like. But nobody really knows what the summer is going to be like. We can just look at all these inputs. I think the suggestion is it's probably going to end up being a little bit warmer than average, and I think there are a number of indications that suggest it might be a little bit drier than average. I did not just say there's going to be a drought, but that seems to be the trends that I'm seeing.
So there you go. Talk a little bit more about the scientific evidence out there that maybe is suggesting a warming of the planet. Mm-hmm. Is that true?
Let's get away from the word "true," because when I'm talking about weather, and when I've spent my life in it. As a scientist, we try to pull back from truth and get into fact. And that's with the understanding that facts are a little bit transient. Facts change as new evidence and new ways of testing facts and of methods come into play. I think everybody needs to understand, though, that the idea of climate change did not begin with somebody observing a warming and let's find a solution to this. Going way back into the 19th century, scientists observed that there was a dramatic increase in carbon dioxide in the atmosphere, and that this change in the physical chemistry of the atmosphere must have some effect because of the greenhouse effect. And so the idea that we might be warming the world by burning fossil fuels is not new. It's been around a long, long time. Finding evidence for it and supporting it and trying to predict the future of it, that's relatively modern.
Mm-hmm. So what is your opinion of extreme weather patterns of, like we just talked about, one bad winter to one mild winter?
Yeah. Well, an interesting thing about North Dakota weather, the state cold temperature record of 60 below at Parshall, North Dakota, the coldest temperature ever measured by an accepted standardized instrument, was in February of 1936. The hottest temperature ever measured in North Dakota was at Steele of 121 degrees, and that was in July of 1936. So the coldest and the hottest temperatures in the state happened in the same year. And 1936 is way before we got really excited about climate change. So our weather has always gone from this extreme to that. So again, where do we find evidence of climate change? We find it in things that are a little more subtle to observe. For example, if you look at any weather station in the state of North Dakota, 20 below nights, they're happening at about half the rate that they did 100 years ago. If you take a 5 or a 10-year running average. Any given winter can be cold or not cold. Any given winter can be mild or not mild. But if you take like a 10-year running average, there'll be more winters in the last 30 years that feel more like this one, and they're a little harder to find 100 years ago. Summertime, the difference is actually shows up more with humidity and the nighttime temperatures. We find that because our weather here in North Dakota has generally, as it has over the last few years, grown a little wetter. Think of the floods in recent years. We're adding more humidity to the atmosphere, and there are a number of reasons for that, and it's not all climate. Some of it has to do with the fact that we're growing some really robust crops of soybeans, and evapotranspiration actually puts water vapor into the air. But we see in the summertime those warm, sticky nights, those nights. I use 65 degrees as a benchmark. Nights that don't drop below 65, those are happening at about twice the rate now over a 5 or 10 year running average than they were 100 or so years ago. And now all of this, you have to look at the data. And I've always been I'm a natural born skeptic. So what's wrong with the data before you start jumping to conclusions? Almost all of the long-term weather stations in North Dakota are in cities, and those cities have grown. And so there's a certain amount of heat that comes from tarmac, particularly in wintertime and particularly at night. And so we notice that the nights don't get as cold to some extent because instead of a bare field covered in snow in winter, we've got a bunch of parking lots, and that gives off a little bit of heat. Not only that, but we have all these buildings and cars that are giving off heat. So there's a certain amount of the warming that you have to realize is actually urban based. And there's a certain amount of the warming that we measure that comes from plants, that comes from evapotranspiration. If the dew point is higher, it doesn't get as cold as night. But you can sort through all of that. You can look at dew points in wintertime. You can look at rural weather stations like the North Dakota Ag Weather Network stations, which are entirely rural based out in fields. And you can still see that there is a climate change in North Dakota. There is a definite warming. And over the last 100 years, the rough estimate is about half of it is natural, and about half of it is probably due to greenhouse.
Yeah, what are the potential dangers of a slowly warming planet?
You know, if we get fewer nights of 20 below, a lot of people would say that's not a bad thing, right? The danger is change, and climate can change naturally too, and does. For example, look at the Devil's Lake area in North Dakota, which I remember I did a speech up in Devil's Lake in the spring of 1992. And at that time, there was a lot of talk about putting in a pipeline to the Cheyenne River to get water into Devil's Lake because the fishery was really suffering because the lake levels were so low after the drought in the 80s. And of course, that recovered dramatically in the 90s, and it's still very high. Recovery isn't a great word. It's been a blossom, right? Devil's Lake is a good way of looking at how our climate can change. And there are some human factors. Farmers in the spring work their fields so that we can get moisture out of the soil a little more quickly for a little more planting. That's not the reason Devil's Lake is flooding. The main reason is that we're getting more rain than we used to, but there are some natural things too, like ditching and straightening of rivers and tributaries and that sort of thing. But in the bottom line, we can still see that there has been a definite change in the climate, and some of it is very clearly caused by greenhouse. What are the dangers of it? You have to think globally, first of all. It's getting expensive. Most Americans live within 25 miles of the coastline, and the coastlines flood. And as the ocean rises, as glaciers gradually melt, those floods get more expensive, and eventually you have to do what we're doing in Fargo. You have to keep the water out. You have to build up or pull back, and that's very expensive. Decades from now, agriculture may look very different in North Dakota because of the change in climate. It looks quite different now than it did when I got here in the mid-1980s. We don't grow much barley anymore. We grow a lot more corn, and our soybeans look thick and rich, and all of that there are all kinds of agricultural changes. Some of that in the future will simply be because as the warming continues, we're going to see changes in yields based on the climate. For example, in the last few years, yields are fantastic. Part of that is because as our summers have warmed, our rainfall has increased. Model projections into the future, decades from now, not next summer, not the summer after that, but decades from now, are that the increased temperature will be such that evaporation will dominate the increase in precipitation. And so at some point you will start to see basically our state getting drier. And that will then force probably some different agriculture than what we see today.
John, let's go back to you a little bit. Tell us about your job and how you forecast, and how has technology really changed how you look at weather patterns?
Well, I got into this when weather modeling was still very simple relative to today, but I never tried to forecast. I never had to try to forecast the weather without the models. That was back in the 70s and before. I started weather forecasting, in college in the early 1980s. The models weren't very sophisticated, so we had to learn to do a lot of forecasting based on analysis of conditions, which I think has helped me because kids today, young meteorologists today come out of college with these computers that say, give you a map of the world, and these are all the temperatures in all the cities and what they'll be hour by hour. And, we didn't have that. But one thing that I try to do is I try to keep our WDAY forecast an entity unto itself. And so that is to say, if you watch us in the morning, the forecast for Saturday afternoon, the high temperature Saturday afternoon, is going to be the same no matter which show you watch throughout the day, no matter which meteorologist is presenting, unless we as a unit agree to change that forecast. We try to hold that forecast entity as a continuum. That way the audience knows what we are thinking about. We're not reacting to the latest model whim. And so I think that provides a little more consistency. And we forecast storms in the same way. We get together in our office, we talk about it, we decide what a storm is most likely to do, and then we stick to that forecast, and then if we're going to change it, we change it as a group. And so if you watch us today, tomorrow, the next day, if the forecast has changed, it's because all of us have decided to change it. And that's hard to do.
Yeah. What's the worst weather you recall in your years of working at WDAY? You've had different ones, I'm sure.
One thing, worst weather or best weather, right? Why does a meteorologist get into weather? It's not for nice days. The most memorable weather to me was a period of about 3 weeks in the winter of 1995-96, which for probably most North Dakotans is long forgotten because of the winter of 96-97, which was an epic winter and then the great flood in the Red River. But the winter before that was a beast of a winter. And there was a blizzard in January. My son was born. My youngest child was born just as that blizzard was getting started. We brought him home just as it was really going crazy. It was one of the worst blizzards that I've ever seen, in that it was so cold. I think we ended up getting about 18 inches of snow in Fargo, so it was a bad one, with winds up around 40 miles an hour. But most of that time, the temperatures were in the teens and 20s below. And then the 2 weeks that followed that were just all below zero, just the coldest stretch of weather I've ever seen. That was remarkable.
John, we got about less than a minute. Any advice to people who might want to get into this line of work that you're in, and where can they go to find out more information?
Well, in this line of work, be prepared for change, because it used to be everybody watched the weather at 6 and 10, and the media doesn't work like that anymore. So be prepared to find different ways of reaching your audience. And as far as finding information, there's a lot of information out there, but be careful. The internet is an ugly, ugly place. I do write a daily piece in the forum that is, sometimes it's informational, sometimes it's opinion, but I try to put a lot of varied information in there. And if you read that every day, hopefully you'll at least know what I'm thinking about the weather and climate.
Well, John, thanks for joining us today.
Thanks for having me. It's been fun.
A lot of good information. Thank you. Stay tuned for more. The art of making Pysanky eggs is still alive and well in a Ukrainian Catholic church in Belfield, North Dakota. Stephanie Rodakowski-Yesel is a master of the craft, and the detail to which the eggs are drawn is painstaking.
The Pysanky egg tradition, that goes way back. It's way over 1,000 years old. Here you have an egg with a shell, so it represents the tomb. You've got the shell, the white and the yolk, it represents the Trinity. A lot of the ways that they decorate the Pysanky have these symbols of new life on them.
It takes anywhere probably from 6 to 10 hours to do one Pysanky from the start to the finish. Every egg is extremely special. You cannot make 2 eggs identical. The egg starts out to be a white chicken egg. The egg can never be washed because the egg has a film on it for the dyes to adhere to. The eggs are hollow. I use a syringe to take the yolks out and then rinse it out. I'm going to put some lines on it. You want to use a pencil that's really a lightweight lead, because the only way this lead is going to come off is when you're taking the wax off the egg. If you can erase it or just put minimal, that's the best. So I got my stylus, my Kiska, and it has a funnel that you put wax in it. You put beeswax because it'll adhere to the egg the best. Since I emptied the egg, there's a hole on top. I have to cover that hole up with wax because I don't want dyes to be in the egg. It'll be a mess. It's all covered up. Gonna start my lines. Gonna follow more or less my pencil lines. Once I cover everything I want white, you can dab it with blue, green, or purple. And they're intense, very concentrated dyes. So you can use a toothpick and you'll just dab those areas that you want that color. Just let it adhere for a little bit. And then just take it off with Kleenex or a napkin, but be careful not to spread out of the lines. So I've got blue in that area, and I would go throughout the whole egg that I want blue. Now you have to cover that area with wax so it doesn't go on to a different color. Once I have all those areas covered with wax, I'll put it in my yellow dye. You go from the lightest to the darkest. So you go yellow, orange, red, and black. Now, as you know, the egg is hollow, so that means it's really light. I use 2 spoons, and I use the lead. And then I have a cement to put on there. Let that dye for about 15 minutes, 10 minutes. So let's say that process is all done. Take it out carefully. There we go. Let's get some napkins. Dab it carefully. And now I continue to cover everything I want yellow. Okay, so I covered everything I want yellow. I would put this egg into my orange dye. I took my egg out of the orange dye. And now I want to cover everything I want orange. Then I would put my orange egg into my red dye for about 10-15 minutes. Take it out of my red dye and cover everything I want red. I covered everything I want red. So then I put the red egg into my black dye. I take it out of the black dye, and that's my final process, and that's what it's going to look like. Then I put it in a plate in the oven. Set the oven maybe 250, just barely warm. Let it preheat for a few minutes. Put the egg on the plate with the cloth. If you don't uncover that hole, the heat in the oven will make the egg blow up because the heat expands. So once I'm in the oven, I'll take the wax off slowly and try to undo this hole the best I could. Set the oven back on 210 and just take the wax off slowly, back and forth. It takes half an hour. So then my wax is all off, and here's my egg. From the white egg to the completed egg.
Well, that's all we have on Prairie Post this week. And as always, thanks for watching.
Funded by the North Dakota Council on the Arts and by the members of Prairie Public.